Hello dear students, welcome you all to Sri Vidyaniketan Public School online chemistry classes. Today I am going to discuss with the functional group and other topic it is about homologous series. So before going to the topic homologous series, you should have an idea of what is this functional group. A simple definition you have, functional group is nothing but an atom or a group of atom or a group of atom which is attached to carbon compound, which is attached to carbon chain or a carbon compound, and that group is going to decide the function of the carbon compound. It is going to change the property or the function of that carbon compound. So those type of a group, those type of atoms are called as functional groups. So simple, it is an atom or group of atom. It is an atom or group of atoms which are going to attach. They are going to attach to the carbon chain and they decide the property or the function of that carbon chain. So those type of atoms or the group of atoms are called as functional groups. Simple example here students. If you are coming for first member of a carbon compound, it is ethane, CH4. This is the formula. And how many hydrogens? 4 hydrogens are there. This is a simple and first member of carbon compound. In place of hydrogen, if you remove hydrogen and it is replaced by chlorine atom, a single atom I am going to attach here. So this chlorine atom is going to change the function of the carbon compound. It is going to decide the function of the carbon compound. So this we can say it is a functional group. Clear? Any atom, a single atom, it may be a single atom or the groups of atoms are going to attach it to the main carbon compound. This is your carbon compound actually, right? Initially hydrogen was there, hydrocarbon, a simple hydrocarbon is there. To this, a group of atom, a single atom or a group of atom, if it is attached, then the function, initial function of carbon compound is not showing now, it is changed. Which is changed here? The chlorine is attached or the functional group is attached and this group is going to decide or it is going to change the function or the property of that hydrocarbon. So that type of atoms which are attaching, those are called as functional groups. Okay. Now let us go with the functional. Yes, dear students, in that functional group, the first functional group I am taking here, it is the first one, it is about halogens. Halogens are nothing but like chlorine, bromine, iodine, fluorine. So all these are halogens and the general formula we can take here CnH2n plus 1 X. Okay, CnH2n plus 1 X. Already you know CnH2n plus 1. In place of plus 1, if it is a plus 2, it's nothing but hydrocarbon, right? Carbon and hydrogen attachment is there means. So these are called as hydrocarbons. To this, X is attached. X in the sense it's nothing but halogen. Okay? Generally we are taking a symbol X. X in the sense it is nothing but halogen. If halogen is attached to hydrocarbon, so this hydrocarbon can be written as R, alkyl group or. So to this R, if you are going to attach X, then this X is going to show the function to the R. X is a halogen. So this halogen, if it is attached to hydrocarbon, then the function of the hydrocarbon, the property of the hydrocarbon is going to change. And that property is decided by the group which is attached to the main carbon compound. So here the group name is halogen. Okay. The group name which is attached to hydrocarbon is halogen and it is represented by using the symbol capital X and the general formula for that halogens are CnH2n plus 1 X. Okay, one of the hydrogen is replaced. I was giving example, simple example. C in place of C, N is equals to 1 is there and H is equals to 2. 2 into 1 2 only plus 1. It is nothing but H is equals to 3. Okay. X. In place of X you can take chlorine, you can take bromine, you can take iodine or you can take fluorine. So in place of X, I took Cl. 1X, Cl. Then it's nothing but CH3Cl, which I have shown up diagram just now. It's nothing but C with the Cl is attached here. Hydrogen, hydrogen, hydrogen. So this chlorine is going to decide the function of the hydrocarbon. This is the first functional group. Then when we come to the second one, I am taking alcohol. The second functional group is alcohol. So if any OH group is present, hydroxyl group, OH group in the sense hydroxyl group. If OH group is present in the main carbon compound, if OH group is attached to the hydrocarbon organic compounds, then that type of compounds are called as alcohols, and the OH group is the functional group which is called as alcohol. Okay. So here generally we can give an example, say in place of CnH2n plus 1, in place of X I am writing OH. OH is attached means it is called as alcohol. Okay. For example, generally we can take this as ROH. General formula for alcohol, it is nothing but ROH. R is a alkyl group. Alkyl group in the sense hydrocarbon group where one of the hydrogen is removed. A simple alkyl group will be there. In that alkyl, one of the hydrogen is removed means then those type of compounds are called as alkyl group. It's nothing but hydrocarbons only. In that hydrocarbon, one hydrogen is removed and OH group is attached. Here one hydrogen is removed, halogen group. Chlorine, bromine, iodine, fluorine, any one is attached. Okay. So all OH is a general formula. Then you can write the first member. For example, if you are taking C in place of 1 as it is 1 and H 2 into 1, it's 2 plus 1, 3 OH. So CH3OH. CH3OH. It's nothing but the name of this compound is methanol. The name of this compound is methanol. Actually, the naming is not there. OL is present. At last, the suffix word OL is present means it is nothing but it is nothing but alcohol. So I will write here OL. The suffix word OL is present means those type of compounds. In the name OL is present means those type of compounds are called as alcohols. And in the structure, if OH group is present means those are called as alcohols. So this is about the second functional group. Then the third functional group, I am going with the third one. It is aldehyde. Aldehyde. So aldehydes are represented by using CHO, carbonyl group. CHO group. Carbon, hydrogen and oxygen will be present. And always this carbon, hydrogen, oxygen, carbon with oxygen group will be present at the corner, at the end. It may be at the terminating level, at the end of the chain, or else in the initiating position, in the sense at the first position of the main carbon chain. So when the CHO group is present, then that type of compounds are called as aldehydes. Generally, general formula we can use CnH2nO. CnH2nO is the general formula. For example, you can give an example. See, carbon with other carbon is attached here and double bond OH. Double bond OH. So here hydrogen, here hydrogen, here hydrogen. So this is what representation. How you will represent this one means carbon with a double bond OH. So here also H, here also H. So like this, if C double bond OH is present, C double bond OH is present at the end of the chain or else at the first position of the chain means then that type of a functional group is called as aldehyde. Hope you understood what is aldehyde. Aldehyde is a functional group which is containing CHO carbonyl group, and this carbonyl group will be attached to end of the carbon chain or else at the first position of the carbon chain. So that type of a group is called as aldehyde. Then the fourth one, it is ketone. Ketone group. So this ketone again is represented by using CO. Okay, or you can write this as like this also, C double bond O here. So this is R, this is R. R in the sense a straight chain of carbon compound will be present, and the general formula here CnH2nO. So you got it out now. Aldehyde also having the same general formula CnH2nO. Even ketone also having the same general formula CnH2nO. Dear students, when I was explaining about aldehyde, I said that aldehyde group will be attached to carbon chain at the end of the carbon chain or else at the first position. If it is in the first position or at the end, then that type of a CHO group is called as aldehyde. If a same C double bond O group is present in between two carbon atoms, always ketone group will be present in between two carbon atoms. So ketone group will start from third member. That in the sense you have to take n value is equals to 3, not 1, not 2. So it is not coming. If it is 1, it becomes aldehyde. If it is 2, it becomes aldehyde. If it is 3, it have a possibility to show aldehyde or ketone. Then how to identify whether it is a ketone or aldehyde means aldehyde group in the sense C double bond O group will be attached to end of the carbon chain or else first position of the carbon chain. But ketone group will be in between two carbon atoms, at the middle of the two carbon atoms. Okay, so I represent it like this. C will be in between two carbon atoms. Carbon atoms are nothing but R. In between them, C double bond O group will be present. If like this is present means those are called as ketones. Okay, a simple example, I am taking third member only. In place of n, if you are taking 3, so C3H 3 2s are 6O. Okay, like this formula came. Suppose if you are writing C3 carbon, 3 carbon atoms, so 3 carbon atoms I have written, then 6 hydrogens are there. In that I am saying it is ketone. Ketone in the sense this oxygen group will be in between two carbon atoms, so give that oxygen at the middle in between two carbon atoms, and remaining will be satisfied. The carbon atom will be satisfied by hydrogen. The valency of a carbon is satisfied by hydrogen. How many hydrogens are there? 6. So 1, 2, 3, 4, 5, 6. Okay. If a oxygen atom is in between the carbon, in between two carbon atoms, then this is ketone. So this is ketone. If you wanted to write same formula for aldehyde, same carbon, and oxygen is not written in between two carbon atoms, but it is written at the end or else at the first position. At the end or else at the first position. So how written here? At the end position, you can write outside or downside or here hydrogen. So all these are satisfied by using hydrogen. So same general formula you got now. For aldehyde also same. For ketone also same. Then where you are going to identify them? Oxygen group, if it is in between two carbon atoms. Oxygen group which is attached here, that if it is in between two carbon atoms, this is ketone group. If the oxygen group is attached at the end of the carbon chain or else at the first position of the carbon chain, then this is nothing but CHO group in the sense aldehyde group. So this is about your functional group, and the last another functional group you have. Number of functional groups are there, only which are needed for 10th syllabus. Only them I am explaining only them. So let us go with the next one. It is carboxylic acid. So this carboxylic acid is again having the formula CnH2n plus 1 COOH. CnH2n plus 1 COOH. If COOH group is present, means then this is called as carboxylic acid. Acidic group will be present in the carbon chain. Okay, so this is a general formula. If you wanted to write a simple example, CH3COOH in place of N value is equal to 1, C1H3COOH. If you are taking N value is equal to 1, CH3COOH. This is the first member of carboxylic acid. Clear? So this is first member. And while giving a name, you have to take suffix word oic acid. For carboxylic acid, you have to take a suffix word oic acid. For ketone, you have to take suffix word one. One. For ketone, suffix word is one. Simple example I took here now. How many carbon atoms? 1, 2, 3. 3 carbon atoms means it is called as pro. Okay. 1 carbon atom is there means meth, methane. 2 carbon atoms are there means eth. I will write here. See, 1 carbon. If 1 carbon is there means meth. 2 carbon atoms are there means it is eth. The prefix word is eth. And the 3 carbon atoms it is pro. And 4 carbon atoms it is called but or but. Don't read it as but, it is but. So here 1, 2, 3. 3 carbon atoms. Due to that what we can say 3 carbon atoms means we can say that it is pro. Okay. If pro is there and a functional group here is ketone. The functional group ketone in the sense you have to take suffix word one. So propanone. Propanone is the name of this compound. Hope you understood about functional group. So functional group is nothing but an atom or a group of atom which is attached to main carbon chain. A group of atom or an atom which is attached to main carbon chain and it is going to decide the function of that carbon chain is called as functional group. And the functional groups I have discussed now: halogens, then aldehydes, alcohols, ketones and carboxylic acid. Okay, let us go with the homologous series. Yes students, homologous series is a group of organic compounds having similar structure and similar chemical properties. Having similar structure and similar chemical properties, and the successive carbon compound will be having differ in one CH2 group. The successive carbon compounds will be having a differ in one CH2 group. Hope you are not understanding whenever you are reading this definition. With some examples you will get it easily. Simple, you take a definition, just you write the definition. A group of organic compound which are having similar physical structures. They are having a similar physical structures and even though they are having a same chemical properties, same chemical structures, but whenever you are going to arrange them in a group, and that successive carbon compound, successive in the sense one after the other, the successive carbon compound will be having a differ in one CH2 group. That in the sense one carbon and 2 hydrogen, they will be having a differ in one carbon and 2 hydrogen group whenever you are going to write the same group of atom. Suppose if you are taking alkane, so alkanes or all the alkanes will be having a similar same structures. I will go with some examples. Okay, see when move with the examples, already you know this alkane is having CnH2n plus 2 as a general formula. The first member of alkane, if you are taking n value is equal to 1, so C1H4, 2 into 1 it is 2 plus 2 it is 4, C1H4. Then n value is equal to 2. If you are taking 2, C2H6 because 2 2s are 4 plus 2. It is nothing but 6. N value if you are taking 2. Then if you are taking n value is equal to 3, then C3H8. If you are taking n value is equal to 4, C4H10. So in this what you can understand, see from here to here, this is the first member, this is second member. After first member, the second member is called as successive member. Okay, so the successive member is showing a differ in one carbon. Is it right? See C1 and C2, only one carbon is differ here. So one carbon, and here to here hydrogen, 2 hydrogens are going to be changing. See, in first member 4 hydrogens was present, and in the second member there are 6 hydrogens. That in the sense the differ in between 2 successive carbon compound is 2 hydrogens. So if you come to the next succeeding member also, see C2 and C3. How many carbon atoms are differ here? And again here same one carbon atom. H6 and H8, again two hydrogen atoms. So whenever you move from top to bottom, in each succeeding member of that organic compound, there will be differing one carbon and two hydrogen atoms. Okay, and all the carbon compounds, all the alkanes which are having a general formula CnH2n plus 2 will be having a similar character, similar physical forms, and even though they will be having the similar chemical properties. Okay, the structures also same and the chemical property also same, but they will be different physical properties. I will discuss it later. When it comes to alkene, the first member, if you are not going to take, if you are going to take C1H21, this is not possible. So if you are taking n value is equal to 1, 2 into 1 it is 2, so carbon will not get satisfied. The valency of carbon is not going to be satisfied. Due to that, you have to take C2 and H 2 into 2 4. This is the first member. This is the first member of alkene. Then the second member, if you are taking n value is equal to 3, so C3 and 2 into 3 it is 6 H6. Then fourth member C4, sorry third member, in place of n, if you are taking 4, 4 into 2 it is 8, H is equal to 8. See again C2, C3, there are one carbon and two hydrogens are different. And again from C3 to C4, one carbon and two hydrogens are different. So here also same you got. Then when you move with the alkyne group, so here also in place of n value, you are not possible to take a n value is equal to 1. So because carbon will not get, the valence of carbon will not get satisfied, just you go with the 2. If you are taking n value is equal to 2, C2 and H 2 into 2 it is 4, 4 minus 2 again it is 2. So CH2. C2H2 is the first member of alkane. Then second member, in place of n if you are taking 3, after 2 you have to take 3. So C3 and 3 into 2 6, 6 minus 2 it is 4, H is equal to 4. Then C, after 3 you have to take 4, C4. Okay, and in place of n 4 you have to, 4 2s are 8, 8 minus 2 it is 6, so H 6. Here also the first member to the second succeeding member you are having differ with one carbon and two hydrogen, and here also one carbon, two hydrogen. So based on this, what you can understand, whenever you are going to write the carbon compounds, whenever you are writing the carbon compounds, in that carbon compounds, a group of carbon compounds will be having similar structure, even though alkanes, all alkanes are having same chemical properties, all alkenes are having same chemical properties, all alkanes are having same chemical properties. So similar chemical properties are present, but there will be different one carbon and two hydrogen in their succeeding member, in their succeeding next members. So due to that, this type of a group is called as homologous series. So based on this, we can say properties of homologous series also. Very easy students, properties of homologous series. So in that, the first property itself we can say, all these homologous series, the group of homologous series will be having same chemical properties. Same chemical properties. There is no change in the chemical properties. Same chemical properties. And the second one, these homologous series, the succeeding member will show differing physical properties. They are going to show differing physical properties. Physical properties are different. Why? Because from first member to second member, there will be change in the total weight. That I will go with the third property. See, homologous series is having a differ in one carbon and two hydrogen. It is having a difference for the succeeding member with one carbon and two hydrogen. This will also become the property of homologous series. Then based on this, one carbon is having 12 gram. Already you know it is having 12 gram, and hydrogen it is having 2 gram. Total 14 grams or 14 unified mass. Atomic mass I am saying. So the atomic mass, the differ in the atomic mass from first member to second member, then to the succeeding member will be about 14 unified mass. You can take it as U, 14 unified mass. This is another property. So these are the properties of homologous series. The first property, all the homologous series, the group of carbon compounds will be having similar, same chemical properties, but they are different physical properties. Okay, and they are going to differ. They are showing a difference in one carbon and two hydrogens in their succeeding members. And they are also going to show the differ in 14 unified mass. How it is 14? If there is differ in one carbon and two hydrogen, means the total weight of that molecule, the atomic mass will be 14 grams or 14 unified mass, right? Due to that, the atomic mass in the succeeding groups, the difference in the atomic mass in succeeding group will be 14 unified mass. So this is about the homologous series. Yes, dear students, you can write homologous series for even the functional group what I have explained. It is like alcohols, even though carboxylic acid, ketone, aldehyde. Try to write those homologous series. If you are not getting, just approach your teachers there. Even though in the worksheets also I have given the general formula, all those which will be easy for you to write the homologous series. Hope you understood about this homologous series. Just try to write the different homologous series for ketone, aldehyde, then alcohols, carboxylic acids, halogens. So like 5 functional groups what I have explained. You by using those general formula, try to write the homologous series.